and I'm the Executive Director of the Sustainability Management Association. We're an international society for professionals around the world that are interested in managing for sustainability. And if you just wait just a moment, I'm going to go ahead and mute our audience at this time. And what I'd like you to do is if you could find the chat bar and be able to enter any questions or feedback that you have in the chat bar, that would be fabulous. And so I'm just going to go through and give you some information about the Sustainability Management Association. And we do have one of our board members on the call this morning. Good morning to you, UT. UT is a postdoctoral research assistant at Dominican University, and her specialty is in environmental science and engineering, and has a wonderful background and really speaks to our mission about really transforming leadership and looking at innovation and technology about how we can create solutions for future generations. And the SMA is really focused on creating widespread knowledge, skills, and abilities to manage for sustainability in any sector, whether it be the government or any type of industry or nonprofit entity. And we have 3 services. Our first is membership. Membership is open to anyone that's interested in sustainability management, and it's such a wide scope because sustainability can be practiced in any position, in any type of industry as well. For those of you who would like a competitive advantage by having a certification, the SMA is the accrediting body for the Sustainability Management Certified Professional and the Sustainability Management Certified Associate certifications. And just like you are attending these calls, your continuing education credits to maintain your certifications can be done through these webinars or through other training or seminars that you attend as well. So those are our 3 services that we offer to people. And just to give you a little bit more about certification, there's a higher tier, the SMCP, which is for professionals who have 2 years of experience working in sustainability. And then our certified associate are those professionals or students who are learning about sustainability and want to be exposed to a body of knowledge with the frameworks and methodologies in sustainability. Those frameworks and methodologies on the KSAs are really about start with strategic management, about seeing your long-term vision, and then being able to use closed-loop management and triple bottom line to manage for people, planet, and profit, to really think about how do we utilize our resources, our human, our natural, and our financial resources, and then to be able to quantify those with very simple metrics, as we'll talk about in today's webinar on energy management, and then how to really pervade that through your own internal organization and also through your external stakeholders, through your supply chain and also your value chain as well. And so if you'd like more information, we'd invite you to please visit our website, sustainabilityma.org, or you can certainly email me personally, and I'd be happy to answer any questions you have or give you some additional information about the study materials and the certification exam. We do offer that exam online to make it accessible to people around the world and to make it a good way for you to learn about sustainability as well. And this is the link to the study guide through Kendall Hunt Publishing, and this is where all of the test questions come from for the certification exam. Our board of directors are highly engaged in sustainability, and we're super lucky to have them. And Amanda Fairley is out of North Carolina. She's our president. Jeff Hoyton is from California in the Bay Area. And Michelle Vicentin, our treasurer, is from Sacramento area in Elk Grove. And George Barber is in my backyard in Paradise Irrigation District. Brandon Morton hails from Texas. Jim Wagner is from Chico, California, and Mark Hindleberger is out of the Sacramento region as well. And UT Hang is out of Dominican University in, I believe, San Mateo, and you'll have to forgive me, UT. So we highly believe in hosting guest speakers through these webinars that are going to be able to help us to understand the newest technologies and innovation that are available to us and be able to design our commercial space to be energy efficient, to understand how to manage that, and then understand how we can truly make a difference and pass that on to our customers. And so we have a mission to really transform leadership through strategy to create a healthy society, environment, and economy. Our next webinar is scheduled for November 3rd. It is at 10 a.m., November 3rd at 10 a.m., and our next host will be Emergy on flow battery technology. And for today's webinar, I'd like to introduce our guest speakers. Russell Garcia is from Johnson Controls, Inc. He is the director of the West region. And Gary Van Winkle is the account executive at MCOR Mesa Energy, and he is the account executive for them as well. So we invite you to listen to today's webinar. Please feel free as you go through the webinar to type your questions into the chat box. What we'll be doing is asking you to type your questions there, and about 11:45 Pacific Standard Time, we'll go ahead and stop and ask people and answer those questions that you've typed into the box. And if you'll just give me one moment, I'm going to go ahead and turn over the controls to Russell and Gary. And Russell, I'm turning over the controls to you now. And thank you so much for presenting today's webinar. We truly appreciate your time, and we're very excited about all that you've been able to achieve in sustainability. And excuse me just one second. I believe I had Russell muted there. I apologize, Russell. You are now unmuted.
Okay. Good morning, everyone. Thank you, Angela, and thank you to the Sustainability Management Association for allowing us the privilege to present to everybody today on this webinar. And Angela, Gary and I were just wondering on your last slide, which one of us was the grizzly bear on the picture?
You know, bears. I live in Northern California. This is one of my favorite animals out there. And this one was captured in Yellowstone. The picture was captured, not the bear, sorry. So it doesn't matter. There are 3 baby cubs that are not in the picture, so you can decide which one of you wants to be the cub or the mama bear.
All right. Well, you know, bears are sustainable, so that's a good reference point. Okay. Well, just to put a little bit of humor into our presentation. So what we're presenting today is smart buildings for a smart grid, and walking you through a 24-hour period of what a smart building looks like today. And what it will do is provide insight into, one, the newest technologies, products, processes, and methodologies that are being used to create a smarter building that's tied into an electricity grid that has a minimal impact on using energy. It has a minimal impact on the environment by trying to reduce consumption, and it's really trying to show all the different ways that efficiency can be placed into a building, from the building management system to the energy storage to renewable energy, and in addition to predictive cost analysis, which what we'll show here when we go through the slides is, you know, starting at 8 p.m. the day before, you'll be able to see where the electricity prices are at and how we're able to predict what the load should be on the building and how much energy we should be able to draw in to keep both costs down and our consumption of energy with these facilities. So with the bar at the bottom of each slide, you'll see the building power demand, and you'll see a typical profile of a building, and that's the big green space. As the building operates through a 24-hour period, you'll see the dotted line is what a smart building profile is, and you'll see a straight line which the electricity price is. And what the idea is to create a steady curve of using electricity from the utility plant and try to offset any sort of demand costs that building is experiencing throughout the day. So that's what you'll be seeing through the slides. This smart building is mostly designed around a mid to large size commercial building, so with the central plant, central heating and air conditioning, and then Gary, towards the latter part of the presentation, will go into some of the different ways that the smaller to mid-sized commercial buildings can leverage some of these types of products and technologies. So with that, I'll kick us off here. So the day before, with this facility at 8 p.m., planning for tomorrow, the system with the building management controls is already looking at tomorrow's weather forecast and seeing temperature, it's seeing if it's partly cloudy, if there's any rain forecast, to determine what type of heating or cooling the facility is going to need, what type of pricing the utilities are putting out the day before, and that's how they do their pricing. They'll put out their costs the day before so we can get an idea of what their flat rate is in addition to their peak demand. And then if the facility has any sort of thermal storage component to it of how much ice the building needs to store ahead of time. In addition, you could also draw on energy for stationary energy storage that day before as well. So coming into the following morning, the system at 4 a.m. could see any sort of default within the building automatically, such as a chiller fault detected, to where the building could send off an alarm that says that there's a chiller fault issue, and that the system can automatically calculate any sort of on-site fixes, or it needs to call in any sort of repairman before the system actually starts getting run and people are starting into the building. That's one thing it can do. And then also it can start to calculate the costs associated with the fault based on any real-time pricing, and it forecasts it. And then the system can do any sort of automatic work order to the facility manager that they can then go to their service provider to fix the chiller before the building comes online. Going into 7 a.m., that order could already be repaired because the request was already put in. Technician arrives, makes the repair before the facility comes on. As opposed to if there was not any sort of that capability within a smart building, then what would happen is that the facility manager would usually come in, see that there was some sort of problem within the system because if there's a heating or cooling issue, he'd have to investigate it. Then you'd have to call out the repair guy, and that typically that repair would get repaired sometime in the mid to late morning. So there would be issues with tenant occupancy. So going into 8 a.m., you have people coming into the facility and they're able to charge their electric vehicles, whether it's a Nissan smart vehicle, a Tesla, or any sort of hybrid. They could plug in their cars and then get their cars charged throughout the day. And while they're getting that charge, it's off-peak demand in the start of the morning there, and that will help reduce demand charges. 9 o'clock, people are starting to arrive into their meeting rooms. The building management system has already prepared that conference room, and in the conference room had 15 people in it, and so it sets the temperature so there's a comfortable working space there that has been pre-cooled or heated for those tenants. And then the occupancy and the carbon dioxide sensors provide an override in case there's any additional people that might show up to the meeting. So there's a set temperature that's in the room, and then the flexibility to increase the temperature. 10 o'clock, let's say the CFO wants a carbon reporting report for their any sort of sustainability reporting requirements that they have, that you're seeing a lot more corporate social reporting, even state reporting. Sometimes they'll need some sort of report that shows them what their carbon emissions are. That system can automatically be pulled out of the building management system, or they can go online to some sort of enterprise dashboard that'll show them what their carbon dioxide savings are and what their emissions are as well. So quick reporting to put out to any stakeholders that need that data. 11 a.m., the utility power price triggers an automatic demand reduction for tenant. So the system is already going to automatically reduce the temperatures in the spaces a few degrees. It's going to start to lower the lighting so that when peak demand hits at 12 o'clock, the building has already started to reduce consumption. And that typically doesn't affect the tenants as much because the building has already had a pre-cooled or preheated space, so they're usually comfortable. And if everybody knows, hey, in these couple hours we're trying to save energy, we've reduced the temperature from a couple degrees or up a couple degrees, the lighting is dimmed a little bit, even shut off in some areas that are not being used, all to avoid those extremely high peak demand charges. And just to give you an idea on peak demand charges, when you look at your utility bill, you'll see like in PG&E territory, they may have a flat rate of 12 cents a a kilowatt hour. Well, during peak demand, that could go all the way up to 40 cents a kilowatt hour. And so at the highest part of the day, when your energy is typically up the highest because of all of the use of the building, they're charging the most. So by reducing the consumption at that time, we're able to save a lot of money in peak demand avoidance. 12 p.m. comes around, the power price triggers automatic demand reduction for the building owner, so they're able to start either dispatching ice storage for the cooling if needed, the chilled water set points on the chillers is increased, and then the lighting controls come into place. And then all these actions and the effects are reported back to the utility so that the owner can be compensated for those demand avoidances. And there's a lot of rebates out right now. Demand peak avoidance is heavily incentivized because the utilities don't want to have to fire off another power plant any time in the day to provide more electricity during demand, nor do they want to go out and broker out those higher cost electricity rates from other providers.
Is everyone still there? Hi, I can still hear you too. We might have lost our presenters, and I'm sure they will be logging in as soon as possible. Must have lost connectivity. Still show them logged on though. If you'll just bear with us just a moment.
Hello, good morning. Sorry, looks like the phone died. Can you hear me, Angela?
Yes, we can. No worries.
Temporary difficulty. My phone automatically shut off because we're coming up on peak demand charge. So,
Smart
so that's one
building.
of the ways I'm able to save money here at the office is the phone's automatically shut off before demand charges come on.
You can override the computer, right?
Yeah, so I did an override, so it allows flexibility.
Great.
And I'm going to go back onto the slide. Let's see here. Can you see my screen?
Yes, I can. Hold on just a moment. Now I can't. Let's see. Here we go.
Okay.
Now I can see your screen.
Okay. All right. So that was an intentional shut off just to show you the effects of a smart building there. So we're back on at 2 o'clock where the system can send out alerts via email or text to let employees know, hey, to start unplugging their laptops or start to run on battery power from the hours of 2 to 4 because laptops should typically be able to run a couple hours. And so that'll dramatically reduce the plug load, which ends up being really substantial in a large office building. So alerts get sent off. Even the desktops can be set to reduce consumption at a certain time as well. And so this is a way that the occupants can become involved in reducing their consumption on the information technology side. Okay, and then 3 o'clock, let's say that there's some cloud cover that causes the solar PV to generation to drop. And when that happens, of course, the buildings are going to have to draw in more electricity from the grid. So when the building receives that demand signal, the system will automatically look to draw in electricity if there's storage available. to meet the reduction goal. So there's a backup plan in the event the renewable energy is not able to supply the facility. If there's a storage component available, it can then draw off there as well. And what you see is that storage container right here. Johnson Controls does manufacture these batteries and creates this stationary energy storage. That particular box is a half a megawatt. And if you put two together, there's a megawatt. So you can have a half or a megawatt on up of stationary storage to be able to use to draw in to help offset peak demand charges. And we have 5:30. We have people leaving the office. So if there's some sort of a scan in out for employees, the system can automatically be tied to that person's badge to turn off their lights if they haven't already, put their computer on standby, and when the person arrives to the parking deck, they unplug their electric car and they drive home. And for people who own a Nissan, that should be just enough to get them home. And for people that own a Tesla, they should be able to drive halfway down the state of California. And at 6:30, the end of the workday, the system looks at all the controls for the lighting and HVAC, and it can be able to follow around those people while they clean the facility. An alternative to that is to do day janitorial cleaning. Sometimes that interferes with occupants, so in the event that there is some sort of after-hours cleaning, the system can be designed to follow them around, along with video surveillance. So that kind of ends the day, and then it takes you back around to 8 o'clock where the system is back looking at the weather forecast for the next day. It's receiving the utility rates the next day, and it's predicting what the load should be on how many occupants are going to be in the facility and what the weather is the next day and what the utility rates are going to be the next day. So that's predictive cost analysis, and that's probably the biggest way that facilities are able to be smarter and tie in with the utility grid. We have a couple of examples of where this type of technology has taken place. This case study is with the Georgia Institute of Technology, where you can see how much energy that they've saved over the course of the months and how much peak demand avoidance they're able to do over the year, and you can see it's upwards of a megawatt. Here's another case study with the Empire State Building. This is a retrofit we did several years back that has this type of capability, and you can see that the savings are instrumental at $4.5 million a year, and I can tell you that's not all of it. So this $4.5 million a year is a big savings to the Empire State Building. Before we move on, I hand it off to Gary. There's another case study I didn't provide. That's a new technology that we've deployed at Stanford University that's called Enterprise Optimization Solution that basically ties in all the types of predictive cost analysis into one dashboard to be able to automate a lot of these things. So if you want to learn more, you can reach out to me, but Stanford's a place that has the smartest technology on the market that we've co-invested and developed with them. So that's the day in the life and a couple of case studies. I'm going to hand it over to Gary to talk about some low-cost solutions for light commercial.
Hey, good morning, everybody. Not everybody has an Empire State Building that they're managing or need to take care of, and there are some solutions on the market for what I call the light commercial market, and that's mostly a tilt-up building with some rooftop units and some possibly VAVs down below. One of the lowest cost solutions, like a single zone or a smaller building, yeah, go down one slide there, Russell, is what is a Wi-Fi thermostat. It's a very inexpensive fix to get control of your facility remotely, control the on-off scheduling, and control the set points, and it's relatively simple to install. There are YouTube videos online to show you how to install it, and there's a helpline as well. And this is just a Honeywell example. There are many other manufacturers that make similar products out there today.
Hey, Gary, I have one of these thermostats, and I got to tell you, this Honeywell thermostat is fantastic. I actually have it on my house, and it's the same one that you use for a building, but it has not only you can control the set points, the times, and such like that, but also has a geofence around the thermostat, which is about a 15-mile radius, to where as you drive away, the system will shut off, and when you drive into that geofence, the system will actually start up and go back to the set point. So really cool and a great way for building warm up or cooling down.
And very simple, good way to control a building that may have just a few zones, or if you want, you can actually do a large building with a lot of zones with it. It's limited a little bit as far as tying to the grid goes, but it would save energy and allow you to up the set points remotely during demand periods or turn it off completely.
Yeah, Honeywell's a good one. There's another one out there called Nest. That's pretty popular, but I like Honeywell too.
There's similar solutions that are wireless that actually will tie your, like if you had a building with 20 or 30 thermostats or a small school or something like that, it'll tie your campus together and would also, in the cloud, store all your data for you. For example, if you wanted to see what the temperature was in a space 2 weeks ago, you'd be able to look back and get that data. In addition, these configurations also allow for auto demand response through your utility provider, which would have some substantial savings with it as well. These are a little bit higher cost than the first solution, but these are lower cost than the traditional hardwired EMS systems for the smaller facility. Yeah. The third example is something that's, I don't know, relatively new to the market, and like I said again, there are more than one company that make these solutions. This is a RTU retrofit solution that actually has substantial energy savings associated with it. Both PG&E and SMUD have rebates available for this technology right now. And what it does is it takes a traditional constant volume, what we call DX package unit, which are probably what's used to heat and cool 75% of the buildings in the United States, by adding a few features to them. What it does is it adds a variable speed drive to the fan. It adds some what's called demand control ventilation, which is kind of like it's indoor air quality. They basically install an indoor air sensor to monitor the CO2 levels and optimize the economizer with that. Most of them contain advanced economization, which is something that the utilities offer rebates for as well. These systems are also wireless, and they report out to central servers, and they can give you history on not only your utility, they'll give you utility history from the day it's installed until the day you decide to quit your software subscription, which is nominal. It's $200 to $300 a year to maintain the software subscription. And currently, the rebates from PG&E are $155 a ton, which can add up quickly. If you do a 30-ton unit or a 20-ton unit, I think you get up to a $3,800 per unit maximum. And most of these systems have a payback of between 2 and 4 years, depending on the run hours of the facility you apply them to. So it's a good way to control and lower your energy bill and cap your energy use moving forward. So that's the advanced RTU solution. It's question and answer time, huh?
Yeah, that concludes our PowerPoint presentation. We can take any questions or comments at this time, Angela.
Well, great. I think that it would be worthwhile to perhaps go back and I was wondering if you could tell us more, Russell, on the building efficiency division. Do you also work with putting in and installing geothermal, biomass, renewable energy systems too, or is that in partnership with MCOR Mesa?
Well, in the division I work in at Johnson Controls, it's called Energy Solutions. We do design and build those types of renewable technologies. They're mostly done on public sector facilities, and federal and state are the more popular types of customers that do biomass, large types of renewable energy type of projects. But yes, we do those, and we use a lot of. We'll be the general contractor, and we'll sub out some different parts of that work. And MCOR is a great partner to be able to have them do any of the installs of mechanical controls, Gary?
That's correct.
Yes.
So when I'm looking at a day in the life of a smart building, you know, many of us on this call, I'm sure, have been hearing about some of the new technologies to be connected to the utility company and to reduce your load by anticipating. And gosh, you taught us so many new words today. I actually have to look through the predictive cost analysis. And I think that that discussion with any CFO would be valuable. You know, the example that you gave us with the Empire State Building and being able to save $4 million, was it $4 million a year at minimum, is, you know, a very good payback. And so that you really, the numbers do speak for themselves now. And with that technologies today, you know, is it the stationary storage, is it able to that offset peak demand? What are customers saying about that? Is it the system will automatically turn over to the battery first before it's going to draw energy from the grid? Or could you tell us a little bit more about that?
Yeah, you know, so the example I gave you had the building management system already had controls that would be tied to the stationary energy storage, so it would automatically trigger the storage to have the inverter switch on to draw on electricity from the storage and not from the utility. So it can all be done automatic with the technology today, but if there's no storage component and there's no technology in place to automate anything, building owners can just automatically go and preset their set points on their thermostats, their set points within their energy management system, or just at that time manually start going off and unplugging computers and turning off lights. And what they'll find is that they're going to reduce the amount of kilowatt hours they're spending during those times, and every time they just do one of those, it's a direct impact to their bottom line. Gary, did you want to add anything to that?
Well, yeah, I don't know if that's part of that, Angela. There's two types of demand response. There's demand response, and then there's automated demand response. And on the automated demand response, they actually get a signal from the utility server saying it's going to be an event day. And then at that point, the BMS system is going to talk to the batteries and tell them how much power they need to make and when they need to start making it. So they offset the incoming power from the grid.
Wow, that's really neat. This is technology that I haven't really caught up on yet. And so you're teaching me a lot today about some of the solutions that are available. And, you know, as I'm thinking about this, do customers need to rewire, for instance, smart lighting that can be integrated with this system? So, because you talked a bit about dimming lights, or really are you using ambient lighting controls for that to be able to adjust the lighting needed throughout the day as the sun goes up and down?
And that would be part of the auto demand response. Everything's automated, and once the signal comes from the utility, everything when we enter peak time goes to its, I guess, its lowest setting for lighting levels. There's also the demand response where the utility provider will actually call you or send you an email, and then you have to go around and some people have to dim switches and manually change set points. And I've seen customers even go around and have their electrician turn off circuit breakers for the afternoon.
Yeah, and when it comes to lighting, there's the controlling of the lighting coming on and off and dimming, and then you got the type of lighting. And today's lighting is LED. I mean, just doing that first, replacing all of your existing lighting with LED lighting is going to have dramatic savings. And then on top of that, if you do put some sort of controls to turn those on and off, then your savings are just escalating there. So there's numerous things that can be done with the lighting below, controlling it, and the type of lighting that you're using.
Okay, thank you. That makes a lot of sense. And right, everyone would really need to be able to reduce their energy usage through, using the best technologies, not only for lighting and air conditioning and heat, but those are really good tips as well. There is a question from Kyle Rasmussen here. I'm sorry, please go ahead. I have a question here from Kyle, and he asked, can constant heating and cooling throughout the day and overnight end up costing just as much as a steady climate?
I'm scrolling up to that one. So can constant heating and cooling throughout the day and overnight end up costing just as much as a steady climate?
So I guess what you're referring to is a little bit like, when I was younger and growing up, I was always told it's cheaper to leave the TV on than to turn it off and then turn it back on again because there's like a peak warm-up. It's most efficient, hopefully this answers your question, to let the building drift at night to a pre-programmed level, such as, in the summertime, if the building gets up to maybe 80 degrees at night, you might turn it back on a little bit just to keep it from getting above 80. And in the wintertime, you might have a setting of like 55 or 60 where you never let the building get below that temperature, so you're able to recover in time for it to be comfortable when the occupants arrive. I'm hoping that answers your question.
Yeah, we talk about that quite a lot as, we're doing energy consultations to really look at, how much energy does it take to actually cool down your appliances, your furniture, your rugs, and all of your interior things to really cool it down to a temperature where it can maintain that. So that was a really good explanation because, I think that a lot of people have that conversation to try to really understand, does it do more, is it better or worse to just leave it at a higher temperature and then try to cool it down for hours and hours and hours?
Mm-hmm.
Kyle, did that answer your question? I'm not sure if he can hear us, but if you'd like to, Kyle, we could definitely unmute you, or we could turn on your chat box as well. I think it was Russell who was talking about the geofence by having the Honeywell, the smart home device to really upgrade your thermostat. I was really interested in hearing more about that. So consumers, it seems like you can almost integrate almost everything into one system right now, from your security system to your energy. If you have smart appliances, that you can control all of that through your cell phone today too, or is that the same system you were speaking about?
Yeah, I mean, most of these technologies can be tied into the smartphone, and you could use them with just a touch of an app. The one I was referring to with the geofence, it's the Honeywell Stat. That's just an additional type of service that they provide to help, save you money and not run your equipment all the time when you're not there. So the thermostat itself has a sensor, and then wherever that app is installed on the phone, there's the other sensor. And when those become more than 15 miles apart, that's when the system can update itself or turn on and off. So that's a little bit about the geofence. Gary, do you want to add something?
Well, there are different systems on the market. I showed the simple thermostat. There are some home systems that do more than just temperature control. They also dim your lights, and they can actually be tied into your blinds and open and close your blinds as well and do other things. Turn your spa on and off. Those are a little more advanced, but they're still relatively inexpensive in today's market. And all of those features could be controlled over an iPad or a smartphone.
That is so neat.
There's some plug-in use types of products right now that you could go and buy right out of an Apple store or a Best Buy. For example, this Honeywell Stat, you can go to Best Buy and buy it, plug it in, and it starts working. There's no sort of install or commissioning needed to start to see this type of technology and savings. There's also Nest that makes a thermostat. They make a carbon dioxide detector that I have as well, and that sends you notifications directly to your phone and turns on and off, and that's wireless. GE right now has LED bulbs that you can unscrew your existing type of fluorescent bulb and plug in an LED bulb, and it'll automatically show up on your smartphone, and then you can tie in all those bulbs into one application onto your phone. And then there's a new LED product coming online for lighting as well. It's going to be from Next. This was some people that worked at Tesla and they went off on their own. That product will probably come online in February, but that's another sort of smart controls for lighting and LED. Some different new plug-and-play type of products.
I'm really glad that LED finally made it down to the residential market. The LED lighting is something that we've been following for a long time, and I think that it's really great for everybody to be getting on the same page to be able to have it integrate with these smart grids and smart buildings, you know. Kyle has a second question for you. It says, does your company construct the buildings themselves, refurbish with this technology, or consult?
Well, I'll speak for JCI, and then Gary can speak for MCOR. JCI, we do new construction, not as a general, but we will do new construction as far as providing any of the work for mechanical HVAC or the controls or the security or any sort of low voltage project management. And then for the retrofitting side, we act as the general a lot of the times where we will design, build the energy project, help select what facility improvement measures are needed with the customer, develop the energy savings model behind that project, and then self-install some of the work and then have subcontractors the rest, and then we end up project managing the job to completion. Gary, you want to talk about it?
Yeah, well, at MCOR, we're a GC, and we're also a mechanical contractor. On a new construction project, we would act as the mechanical contractor and maybe the controls contractor. On a retrofit job, we could do anything from run the whole job to perform the mechanical and the technical controls application work as well.
Gary, does when you install one of these, does the whole building need to be rewired to integrate with the Wi-Fi, or can you tell us a little bit more about what we could expect to have to do to make our building a smart building?
In today's market, you can do it a couple different ways. There's a lot of wireless products. There's also, most customers have an infrastructure in-house where they have a networking in place, and a lot of these systems, or most of these systems, are plugged into the IT backbone of the building. And then maybe the outbuildings are wireless, is how I've seen most of this applied.
Okay, so it's pretty seamless for a customer.
And mission-critical facilities such as a data center or a hospital, you're probably going to see a lot of things still hardwired instead of relying on a wireless network.
Right, just for backup and security and contingency planning, right?
Yep. It costs them so much money if they're down that they'll make any expense to have as much uptime as possible.
That makes a lot of sense. When you had talked about your stationary batteries that can store up to, a megawatt, that's pretty amazing. And so what is that, the lithium-ion battery systems, or could you tell us a little bit more about the actual technology behind that battery?
Yeah, why don't I pop up on the screen a picture of what this looks like, and then I'll quickly walk you through what it looks like in the guts of this thing. So let me just pause my screen here and grab it off my computer. So
sure, that would be great. Because we do have some customers on the call today that have renewable energy systems, and it would be nice to know, is it something that can be easily integrated into their existing system to add a battery system? Because, just a few years ago, I don't even think this existed to be installed alongside your renewable energy install.
Yeah, you're right. I mean, this is in the last few years, and it is because of the lithium-ion battery technology and the efficiency of it. Pre-lithium-ion battery, we looked at storage with using these DC batteries like in your car and just kind of connecting a bunch of those. And what happened is that there's a lot of heat that was created when using those, so there was a lot of risk as far as fires happening or anything like that. And the life expectancy of those DC batteries when used together there wouldn't be a long life expectancy. So how we design the inside of this stationary storage is that you can see in the bottom left corner, you see a common battery pack. So these lithium-ion batteries kind of look like a AA battery. And so we line those up in a rack. And then we put them into like a common rack system, much like what a data rack would look like in a data center. And so you've got racks of all these lithium-ion batteries, and together they act as an electricity coil. And that coil then works together in a system to provide the electricity, in these storage case, a half a megawatt at a time. And so and there's also a battery management system component within that container that can indicate which one of these little common battery packs or batteries are starting to die. Then we could just come in and replace just that particular battery pack. So what we're envisioning is that this has a longer life expectancy. We're not replacing whole systems. We're just replacing parts of the coil that are failing. And so the life expectancies with these are 8 and 10 years plus on out.
That's really good news. Well, thanks for explaining that. That makes a lot of sense, and that picture helps me to, see it, just to even explaining it as like a data center. So that makes a lot of sense to me too. So the size of this battery, it kind of looks like a shipping container.
That's it. It's just picture a shipping container, and if you've got the space to put a shipping container, whether it's in a parking lot, in a field, parking garage, you just place it there. There's an inverter that can be used to any sort of renewable energy or tied right into the grid, and you can build these up. 2 is 1 megawatt, 4 is 2 kilowatts, however much space you had and however much energy you want to have on site.
Very neat. And let's see if I can word this correctly. If you had a battery system, do you still have the option to net meter to be able to, do you have to choose in your system to send the energy to the battery system and then back to the grid, or what choices does the customer have?
Well, with the net metering, you're saying to the utility company that you're going to sell them any excess energy you don't use from your system, whether it's a renewable system or a storage system, and then they'll pay you for that, and then they'll give you a true-up at the end of the year, which is a discount. Now, so they'll never give you, today they won't give you back any money because of the way the law is written. I think in 5 years from now that might be different because there's laws as far as how much somebody can charge to supply energy. So with the stationary storage, I would never see you selling any of that energy back to the grid because they're buying it for like 4 cents a kilowatt hour, and they'll turn around and sell it for a lot more. So with renewable energy systems that don't have a stationary component, yeah, whatever you don't use, the system will automatically send back to the utility company, and then they'll give you a discount on your utility bill because they've been buying kilowatt hours for like 4 cents a kilowatt hour from your system.
Yeah, pretty good deal, I would say.
For them.
Yeah, just so our audience knows, while we're on the subject of batteries, Johnson Controls is the company that you might recognize them the most for, is that they recycle all of the auto batteries worldwide. 99% of auto batteries come back to Johnson Controls to be recycled into new batteries. So figuring out that technology was a huge sustainability pioneer initiative, and they've been doing this since day one, and even your founder at MCOR Mesa, I found it interesting on your website that your founder started in the energy field by creating the first thermostat. So I thought that it was great that you started off your presentation talking about the thermostat today too, and how much has changed since the founding of your company.
Yeah, you know how he did that back in the late 1800s. Late 1800s?
1884.
Warren Johnson, and I think he was a professor at a school, and he was getting tired of every time he got cold or hot, he would have to walk down to the basement to adjust the boiler. And he basically thought of a better way to sensor the boiler with a thermostat in his room. and with a hard wire. So that's kind of how thermostats came about.
That's a good story, and I would suspect he was also probably part of the TV remote then. Having to
Actually, I think that was.
I think they had a TV for a few years, but he lived long enough, he would have.
You know who invented that? That technology came from Nikola Tesla. He invented Wi-Fi technology that enabled remote controls in our phones. So, yeah, all the smart guys are dead and gone.
Right.
We're just holding on to their ideas right now.
Which is so funny because not until a few years back did I even start learning about Nikola Tesla. And so I just always wondered why that was the case, that they don't even teach you that in school. So it's pretty amazing what you learn about Edison and not about Tesla. So,
yeah.
well, you know,
there's a lot of politics with that one.
I think that's the whole reason, right? It's all politics and who funded who and the venture capitals that were behind the whole energy production system and how America went at that time in the 20s. So, well, I really appreciate you helping me learn about this today. It seems as if I would like to update some of the energy information in our study materials for professionals learning about energy because there have been so many changes to innovation in the last couple of years. And as we move forward with smart buildings, it's if we could make energy management seamless for the customer, something that they didn't actually have time to manage or personnel to actually make that a project, that this could be something that could be very useful for many large organizations to really use artificial intelligence to be able to help you control your building's usage as well. And I think that the materials that it comes with, the dashboard and the building power demand, I mean, that is super helpful for all managers to be able to know and understand their peak pricing and how to reduce their costs and be more efficient. So I thank you so much for today's presentation, and if there's anything that we can do, we have a newsletter that will begin posting information about our members. We'd be happy to be putting out information for both of your companies. And so please let us know how we can do that for you, and continue to tweet about your latest and greatest technologies as they come out, case studies that you may have for customers that are going online. And I think that, you know, that the more people can understand about how this can be a seamless way to manage energy, I think that a lot of us need solutions like that because we don't have the personnel or the time to be managing our utilities. And so that's something that's going to be highly valuable in the future. And this is the future, it looks like. This is the way that things will be going. So a lot of people within the SMA are definitely in the forefront of being innovative too and using the best technologies that are out there. You know, I wondered if I wanted to send your information out to a few property managers on both residential and commercial property managers, and I think that that would be a good connection that we could help make for you as well. Do you have any questions for me?
No, I appreciate you reaching out to us and asking us to help you with this today, Angela.
Yeah, thank you, Angela, and thank you all who attended the call. I hope it was helpful.
Great. Thank you, everyone, and have a wonderful day. And your audience is sending in a bunch of chats to say thank you. We really appreciate it, and please keep us updated on new developments and case studies that we can put out for you as well. All right, everyone, have a great day. Thank you so much for attending. Bye-bye.
Thanks, man. Have a good day. Bye-bye.